First principles. To successfully solve problems that involve first principles, it requires that learners be mindful of a number of concepts. That means besides the concept of first principles itself, you need to import or come up with other concepts from earlier topics. Functional notation of substitution, common denominators, laws of exponents, expansion and distributive laws. These are the concepts that you need to have prior knowledge of. Then there are some standard results given the nature of the problem. Whenever it's x plus h squared, it's always going to give us x squared plus 2hx plus h squared. X plus h cubed, x cubed plus 3x squared h plus 3x h squared plus h cubed. These results are very useful to remember. Then it depends on the nature of the problem. There are types of expressions in first principles. The first one is a linear expression. What is key here is to keep in mind the rules of differentiation. The derivative of a linear function is a constant. That's the first one. So if it is linear, it could be f of x is equals to ax plus b. When I spoke of functional notation, that means when we say f of x plus h, when there is an x, you remove and substitute x plus h. That means it becomes a x plus h plus b. Therefore, this becomes a x plus a h plus b. This is what I meant when I referred to functional notation of substitution. So that is the one that is linear. It could be quadratic. If it is quadratic, in substituting f of x plus h, keep in mind that x plus h squared is equals to that. The outcome should be a linear. The outcome, that means ultimately when we are done with the answer. So if we had g of x, a quadratic, would look in this form, ax squared plus bx plus c. Now when you are substituting g of x plus h is going to be ax plus h squared plus bx plus h plus c. To avoid wasting time on this expression, we already have a standard result for that. This is the standard result right here. So keep that standard result in mind. We're going to have g of x plus h is therefore equal to ax squared plus 2hx plus h squared plus bx plus h bx plus bh plus c. Ultimately, g of x plus h is going to be ax squared plus 2ahx plus ah squared plus bx plus bh plus c. It's quite cumbersome. It's to be expected because of the squaring of that expression. So that is the quadratic nature when you're dealing with first principles. If it's cubic, it's even more cumbersome. In this instance, we're dealing with h of x is equals to ax cubed plus bx squared plus cx plus d. We are now going to employ both results because there is an x squared aspect, there is an x cubed aspect. So we would have to employ both aspects. And in this case, h of x plus h becomes ax plus h cubed plus bx plus h squared plus cx plus h plus d. Keeping in mind those standard results, you merely substitute. You're going to get a x squared x cubed plus 3hx squared plus 3h squared x plus h cubed plus b x squared plus 2hx plus h squared plus cx plus ch plus d. Next, now I'm merely distributing the a as well as the b. Ax cubed plus 3ahx squared plus 3ah squared x plus ah cubed plus bx squared plus 2bhx plus bh squared plus cx plus ch plus d. 5 cumbersome. This one is this cumbersome because you had to differentiate, you had to substitute the expression of x plus h cubed, you had to substitute the expression of x plus h squared. Lastly, we've got a fractional variation. The key here is to avoid a cumbersome expression, given that the function is to be divided by h. Therefore, it is advisable to rather multiply by 1 over h rather than divide by h. Furthermore, do not expand the denominator expressions. This one can make much more sense when we are indulging examples. But let me give you a peek view of what it might look like. If we have k of x is equals to a x squared, then k of x plus h is going to be a x plus h squared. But unlike all the others that we've done, therefore it is advisable to multiply by 1 over h and do not expand this denominator expression. There is no need to expand. Do not expand. Do not expand. Unlike the quadratic and the cubic. Why am I saying do not expand? Well, when we do an example, it will become more clearer and you appreciate it even more. If you expand there, it's not necessary because after you do cancellation, you are just merely going to substitute, which makes your algebraic manipulations much more manageable. Okay, without further ado, what are the possible misconceptions? What are the possible misconceptions? The possible misconceptions are the omission of the limit. This, you incur a penalty in notation. Using the power rule to solve the problem rather than the required method of first principles. Learners have a tendency of taking a shortcut. Examiners are well aware of that shortcut. So you won't get away with it. If you use the power rule rather than the first principles, they're going to catch you out because they are aware of any way that you can use to cheat. So these are the possible misconceptions. You need to guard against this. Notation is one, and shortcuts using power rule. Let's do some exam type questions. And in all of them, you are required to use first principles to differentiate the following. Exam type questions. We are given g of x is equals to 2x cubed minus 3x squared plus 4x plus 1. I'm going to divide the board to make space. You are required to determine g prime of x using first principles. Determine g prime of x using first principles. So, step number 1, you have to determine g of x plus h. You are going to say 2x plus h cubed minus 3x plus h squared plus 4 times x plus h plus 1. Thereafter, 2x cubed plus 3hx squared plus 3h squared x plus h cubed minus 3x squared plus 2hx plus h squared. Continues on the other side, 4x plus 4h plus 1. You distribute, you're going to get 2x cubed plus 6hx squared plus 3h squared x plus, this is 6, plus 2h cubed. You are distributing that 2 ways. So it will multiply everything. 2 multiplies x cubed, 2 multiplies 3, which is hence the 6. 2 multiplying the same 3 will get another 6. Then 2 multiplying that will get 2h cubed. Then 3 multiplying that minus 3x squared minus 6hx minus 3h squared. This is already simplified 4hx plus 1. After this, we start to do the expression. G prime of x is equal to, we are always told that g prime of x is equals to limits as h goes to 0 of g of x plus h minus g of x all over h. So I am going to substitute using this expression. Gx of h is this cumbersome expression. Then 2x cubed plus 6hx squared plus 6h squared x plus 2h cubed minus 3x squared minus 6hx minus 3h squared plus 4x plus 4h plus 1 minus. Let me continue on one line. Plus 4x plus 4h minus 1. That resembles this part of the substitution. Minus, put brackets. Why are we putting brackets? So that we accurately distribute. So it's going to be 2x cubed minus 3x squared plus 4x plus 1 all over h. And one thing here, g prime of x is equals to limit as h goes to 0. If you forget this limit, if you forget that limit there, you're going to be penalized for the notation. Having done this, it will become simpler because certain terms are going to cancel. Certain terms are going to cancel. Certain terms are going to cancel. And when you cancel those terms, limit as h goes to 0 of 6hx squared plus 6h squared x plus 2h cubed minus 6hx minus 3h squared plus 4h all over h. Next step, we have to factor out a single h. Even if h squared was common, factor out a single h. Even if h to the 3 was common, factor out a single h. Why? Because we need to cancel the 1 in the denominator. That is the purpose of this. If we were to substitute in this junction and say h is equals to 0, it would create an undefined expression. That's what we're trying to avoid. So, moving on, limit as h is approaching 0, we factor out an h. Just a single one. We're left with 6x squared plus 6hx plus 2h squared minus 6x minus 3h plus 4 all over h. Yet again, this h is going to cancel that h. When it does that, we are now left with a scenario whereby we can now say h is equals to 0. Any remaining h is going to be substituted as a 0. So we're left with 6x squared plus 6 times 0x plus 2 0 squared minus 6x minus 3 times 0 plus 4. No denominator because we cancelled it out. Next, we're going to have, there's no longer any limit. The purpose of carrying the limit down with you is because there will be an h that remains. There's no longer any h. So the limit goes hand in hand with h. The minute h disappears, limit also disappears. So, final answer, 6x squared minus 6x plus 4. That is the final answer. It's cumbersome, I agree. But you have to be diligent and you have to maintain your concentration levels as you work through this, because there are many opportunities for you to make mistakes. There are many opportunities. Earlier on I said, what are the things that learners can do? They can cheat. They can differentiate this using the power rule and go straight to the answer. You're going to lose marks for all this working, the cancellation, all this working that is necessary. So, keep that in mind. What are the key steps? What are the key signposts that you cannot miss out? The method revolves around step number 1, use functional substitution to get f of x plus h. That's step number 1. That is step number 1. Use functional substitution to get f of x plus h. Step number 1. Step number 2. Cancel terms from original function. This has the tendency of leaving terms that have h only. You cancel out terms from the original function. This leaves terms that have h only. Step number 3. Cancel, factor out. Factor out h and cancel with h in the denominator. Step number 4, the final step, substitute h is equals to 0. Those are the 4 steps. So whenever you're doing first principles, it's guided by those 4 steps. If you get these 4 steps right, you're always going to converge on the answer. So just to recap, use functional substitution to get f of x plus h. Cancel terms from the original function, leaving terms that have h only. Step number 3, factor out h and cancel with h in the denominator. And step number 4, substitute. We have done A. Let's proceed to do B. H of x is equals to minus 5x squared minus 4x plus 5. H of x plus h, let me not say plus h, let's say plus k, because of the double h there. This is going to be minus 5x plus k squared minus 4x plus k plus 5. Minus 5 multiplied by x squared plus 2kx plus k squared minus 4x minus 4k plus 5. Finally, we are having minus 5x squared minus 10kx minus 5k squared minus 4x minus 4k plus 5. This is the first step. Use functional substitution to get that. Next step, h prime of x. Be careful with notation. Be careful with the notation there. Limit as k goes to 0. Limit as k goes to 0. It's minus 5x squared minus 10kx minus 5k squared minus 4x minus 4k plus 5 minus 5x squared minus 4x plus 5 all over k. All over k. Step number 2 says cancel terms from the original function. This term is going to cancel this one. This term is going to cancel this one. Lastly, this 5 will cancel that one. That is going to leave us with an expression k approaching 0 of minus 10kx minus 5k squared minus 4k all over k. Next step, limit as k goes to 0. Factor out one of the k's. So that is going to be k. Then we're left with minus 10x minus 5k minus 4 all over k. Final answer, we're going to get limit as k equal to 0. This is now, this k cancels that one. This is now equal to minus 10x minus 5 times 0 minus 4. Final answer, which is h prime of x, is minus 10x minus 4. You just have to follow these 4 steps. Use the functional notation. That's what we did here. So all of this was step number 1. This and that was step number 2. This was step number 3, and this one, step number 4. Following these 4 steps. If you do that successfully, you always converge on the answer. I'm going to keep this here, and as we proceed from question to question, we'll be referring to this. We have k of x is equal to 7x minus 5. This is a linear expression which makes it even more easier. So get k of x plus h is equals to 7x plus h minus 5. K of x plus h is equals to 7x plus 7h minus 5. Step number 1. Use functional substitution to get that. So this is step number 1. Thereafter, k prime x. Always be able to adapt to the notation. If they call the function f of x, fair enough. But if they call it k of x, then you have to work with that. You have to adapt it to the given expression. You have to adapt it into the context of the question. This is equals to limit as h approaches to 0. And this 7x plus 7h minus 5 minus the original function 7x minus 5 all over h. Step number 2, we're going to cancel terms from the original. This will cancel that. This will cancel that. What are we left with? We have limit as h approaches 0. And this is just 7h over h. Final answer. The h's are going to cancel. That was step number 3. Therefore, k prime of x is equals to limit h is equals to 0 or 7. There is no h to substitute the 0. Therefore, k prime of x is just 7. This one is more straightforward. This one is more straightforward because it's a linear function. So what makes it more straightforward is because it is linear. Lastly, we have the fractional expression. We have the fractional expression. So here, before I move on, use functional substitution. We did that right here. Step number 1. Cancel terms from the original. We did that right here. Factor out an h and cancel. That's what we were doing in this step here. And lastly, substitute h is equals to 0. There was no longer any lingering h, so there was nothing to cancel out there. The fractional. This is the tricky one. We have m of x is equal to minus 5x cubed. M of x is equal to minus 5 over x cubed. M of x plus m of x plus h is equal to minus 5 x plus h cubed. Do not expand it. Earlier on we said it's in the denominator. Do not expand it. So you leave it like this. This is step number 1. The functional substitution to get that. Then m prime of x, we said you have to be able to adapt to the context of the question. So adapt the formula, the given expression, to the context of the question. This is going to be minus 5x plus h cubed minus 5 over x cubed. Instead of making it more cumbersome and saying divided by h, rather, let's multiply by 1 over h. Rather, let's multiply by 1 over h. The whole expression, 1 over h. Do not forget the limit. If you forget the limit, you are penalized for notation's sake. So limit as h goes to 0. So instead of dividing by h, I multiply by 1 over h. It's just an algebraic trick to be able to manage that expression. H approaching 0. When you have scenarios like this, you have two fractions. It's imperative that you get the LCD. So multiply the 2. This is just going to be x cubed, x plus h cubed, all over minus 5x cubed minus 5x plus h cubed. Still multiplied by 1 over h. This one in the denominator, the x plus h cubed, don't expand, but this one in the numerator, you must expand. So limit as h goes to 0 of minus 5x cubed minus 5x cubed plus 3hx squared, x squared h plus 3h squared h plus h cubed all over x cubed x plus h cubed times 1 over h. It will cancel everything that was in the original function. This will cancel, that will cancel. Next step, cancel original function. We did that. Factor out in h. Limit as h goes to 0. We are left with minus 15h x squared minus 15h squared x minus 5h cubed all over x cubed x plus h cubed, still multiplied by 1 over h outside. Then at that junction, we say cancel, factor out in h. So this h is factored out. Here this goes away, leaving a squared, but it will cancel that h. So if I were to expand it, this is going to be limit as h goes to 0 of an h outside minus 15x squared minus 15hx minus 5h squared all over x cubed x plus h cubed multiplied by 1 over h. This h here and that one are going to cancel. Coming back to the top, since we've cancelled out the h, limit h equal to 0. Any lingering h that remains becomes a 0. So this is minus 15x squared minus 15x minus 50 squared all over x cubed, then x plus 0 cubed. This is why we didn't want to expand it. Limit, because there's no longer any h, there's no need for the limit. That leaves us with minus 15x squared all over x to the power 6, which ends up being minus 15 over x to the power 4. Minus 15 x to the power 4. That is example D. Then we have a couple of examples, past exam questions. The first one is from Northwest Spelling 2017. Second one, third one. I'm going to start with number 5. M of x is equals to minus 7 over x squared. Minus 7 over x squared. So m of x plus h is equals to minus 7 x plus h squared. m prime x is equals to limit as h goes to 0 minus 7x plus h squared minus, which makes it plus 7 over x squared. Everything multiplied by 1 over h. So this was step number 1. Step number 2 is going to allow some algebraic manipulation where we get LCD of this limit as h goes to 0. LCD is x squared x plus h squared minus 7x squared plus 7x plus h squared, all multiplied by 1 over h. Limit is h goes to 0 minus 7x squared plus 7x squared plus 2hx plus h squared, all over x squared x plus h squared multiplied by 1 over h. Limit as h goes to 0. It has to cancel the original function. Which original function is cancelled here? This one. That is going to be cancelled. That leaves us with 7 times that is 14hx plus 7 by that is 7h squared all over x squared x plus h squared multiplied by 1 over h. Step number 3, factor out h and cancel h with h in the denominator. Limit as h goes to 0. I'm going to factor out an h. H comes outside, leaving me with 14x plus 7h all over x squared x plus h squared multiplied by 1 over h. This will cancel that. Thereafter, step number 4 says substitute h is equals to 0. Limit as h is equals to 0. That means we have 14x plus 7 times 0 all over x to the power 4. Therefore, m prime of x is equal to 14 over x cubed. 14 over x cubed. That is the final answer. And the key is always to follow these steps: functional substitution, cancellation of original terms, factoring out an h, and substituting x is equals to 0 for x, h is equals to 0 for h. That was number 5. Number 5, Western Cape 2017. I'll proceed to do Free State 2017, which is question number 4. Number 4. 4.1, we have g of x is equals to 5 minus 2x cubed. G of x plus h is equals to 5 minus 2x cubed plus 3hx squared, hx squared plus 3h squared x plus h cubed. G of x plus h is equals to 5 minus 2x cubed minus 6hx squared minus 6h squared x minus 2h cubed. This is G of x plus h. That's step number 1, use of functional substitution. Second step, g prime of x is equals to limit as h goes to 0 of 5 minus 2x cubed minus 6hx squared minus 6h squared x minus 2h cubed minus 5 plus 2x cubed all over h. Step number 2 says we have to cancel out terms from the original function. That is exactly what happens. This will cancel that, and this will have the effect of cancelling that one out. Step number 3 says after you cancel out, factor out an h. This is going to be g prime of x is equals to limit as h approaches 0. Factor out an h, that leaves minus 6x squared minus 6hx minus 2h squared all over h. Factor out and cancel in h. That's step number 3. Next step, g prime of x. Say substitute h is equals to 0. Limit h is equals to 0. This is minus 6x squared minus 6 times 0, x minus 20 squared. And lastly, g prime of x is just going to be minus 6x squared. So, to recap, it's paramount that you follow the steps. Use functional notation, functional substitution. That will give us g of x plus h. Then from there, you are going to cancel terms from the original function, just like we did there, the circled green, those terms are cancelling. Step number 3, factor out h and cancel h with the 1 in the denominator. That cancels out. The third step there, fourth step, substitute h is equals to 0. Any lingering or h that's still there becomes 0, and we have g prime of x. Let's do the second part of the question. The line h of x is equals to minus 1x over 8 plus p. Is it tangent to the graph of g of x at point A? Tangent. The word tangent there implies that it's a gradient. So g prime of x is this, and the gradient is said to be m, which is equals to g prime is equal to negative 1 over 8. So negative 1 over 8 is equal to negative 6x squared. From there, we're going to get 1 over 48 is equals to x squared. X is equals to plus minus 1 over 48 root of. This means x is equals to plus minus 1 over 2 root 3. Which ends up being x is equals to plus minus 1 root 3 over 2 times 3, which is x is equals to root 3 over 6 plus minus. Therefore, a could possibly be, for x, positive root 3 over 6, or a could be negative root 3 over 6. The corresponding y, you substitute root 3 into the original function. Y is equals to 5 minus 2 root 3 over 6 cubed. This is 5 minus 2, 3 root 3 over 216. 5 minus 6 root 3 over 216. And lastly, y is equals to 5 minus root 3 over 36, whatever that is. So that is going to be, this was the positive root 3, so it's for this one, 5 minus root 3 over 36. For the negative version, since it's cubed, it's going to be y is equals to 5 minus 2 negative root 3 over 6 cubed. Y is equals to 5 minus 2 negative 3 root 3 over 216. Y is equals to 5 minus plus 6 root 3 over 216. Lastly, y is equals to 5 plus root 3 over 36. Plus, instead of a negative. 5 plus root 3 over 36. These are the possible coordinates for this point A. These are the two possible coordinates. Possible because